Hello everybody. In this video we are going to discuss about the electronic configuration of elements having atomic number 1 to atomic number 30. Electronic configuration means how the electrons are get distributed around the nucleus of an atom. Nucleus of an atom consists of protons and neutrons. Electrons are distributed around the nucleus in different shells, subshells, in different orbitals. In previous video, I discussed about the rules for distribution of electrons. Okay, please watch that first one: Aufbaus principle, Hund's rule, and the Paulies exclusion principle. These rules were get discussed in the previous video. So as to write down the electronic configuration of elements, one should know the rules for distribution of electrons. And besides that, we should know the atomic number of elements and their symbols, okay, and that rules also we should know. So let's begin. So atomic number 1 is of the hydrogen, its symbol is 1. Atomic number 1 means hydrogen consists of only one electron. Its electronic configuration is 1s1. Okay, as per the Aufbaus principle, we know that electrons are firstly entered into the subshell which is having the lowest energy. So first of all, electrons will get entered into the 1s subshell. Hydrogen consists of one electron only, that's why its electronic configuration is 1s1. We can, S subshell is made up of one orbital, that's why we can write it like this. This half-headed upward directed arrow indicates that single electron of the hydrogen. 1s1 is the electronic configuration of hydrogen. Second one is the helium. Its atomic number is 2. Means helium consists of 2 electrons. Its electronic configuration is 1s2. We know that 1s is the subshell. First of all, electrons are entering into the 1s subshell. And here the first electron is of the upward directed, having a plus half spin quantum number, and the another electron having the minus half spin quantum number. Okay, like this we are representing these two electrons of the helium. Its electronic configuration is 1s2. Then atomic number 3 is of the lithium. So its electronic configuration is 1s2 and 2s1. Okay. Yes, you should know the sequence. That's why please try to see the previous video about the rules of distribution of electrons. In that video, the sequence is given. Once the 1s get filled, then electrons will be entered into the 2s subshell. So we know that lithium consists of total 3 electrons, and out of the 3, 2 electrons are present in 1s subshell. 1s subshell is made up of one orbital, that's why one block I showed. 2s is also made up of one orbital, that's why one block is showed. So this is the electronic configuration of the lithium. Okay, 1s2, 2s1. Now let's proceed. Hydrogen, helium, lithium. First 3 elements, their electronic configuration we saw. Then atomic number 4 is of the boron. In case of boron, atomic number 4 is of the beryllium. Beryllium electronic configuration is 1s2 and 2s2. Here we should represent it like this: 1s and 2s. These s subshells are made up of the one orbital only, that's why one block I showed. And 1s2, 2s2 is the electronic configuration of beryllium. Boron, atomic number 5. How the 5 electrons of boron are get distributed? Here in this case, it's a 1s2, 2s2 and 2p1. 1s subshell consists of 2 electrons. 2s subshell consists of 2 electrons, and p subshell, we studied that p subshell is made up of px, py and pz 3 orbitals. Wherever there is a representation of p subshell is to be done, we should show the 3 blocks, means 3 orbitals are there. Amongst the 3 orbitals, here there is only one electron, that's why that electron is in the first orbital. So what is the electronic configuration of boron? It's a 1s2, 2s2, 2p1. Then there is a carbon, atomic number 6. Its electronic configuration is 1s2, 2s2 and 2p2. Okay, in this way these electrons are distributed. Upside number is the number of electrons. So S subshell of first and second, S orbital of the first and second shell can accommodate maximum How many electrons? 2 electrons here only, and 2p2. So as per the Hund's rule, the first electron is in first orbital, second electron is in the second orbital. So this is the electronic configuration of the carbon, very important element. Then there is a nitrogen, atomic number 7. Electronic configuration is 1s2, 2s2 and 2p3. Okay, so I'll make a block for this one, 1s2, 2s2, and just I said p subshell is made up of 3 orbitals. So how these 3 electrons will be distributed? First electron in first orbital, second in second orbital, and third in third orbital. This is about the nitrogen. Now next one, after nitrogen, atomic number 8 is of the oxygen. Oxygen, symbol O. Its electronic configuration is 1s2, 2s2 and 2p4. So we know that S subshell 1 orbital and P subshell is made up of 3 orbital. It's a very easy. So the nitrogen, after nitrogen, oxygen, here we have 2 electrons in 1s subshell, 2 electron in 2s subshell and 4 electrons in the 2p subshell. How to show them? First, second, third, and this fourth electron is get paired, isn't it? Oxygen consists of 2 unpaired electrons, isn't it? That's why it is a paramagnetic in nature, which attracts the electron, atomic oxygen. Then fluorine, atomic number 9, its electronic configuration is 1s2, 2s2 and 2p5. Here 1s2, 2s2 and p subshell made up of 3 orbitals. So here like this, total 5 electrons. Okay, 2p5. So the last only 1 electron is unpaired. Then neon, atomic number 10, electronic configuration 1s2, 2s2 and 2p6. 1s2 here like this, 2s2 here and 2p6. We can show like this, 1, 2, 3, 4, 5th and 6th one. All these electrons are paired in this case of the neon. Now atomic number 11 of the sodium. Okay, now here we can write the electronic configuration of sodium as 1s2, 2s2, 2p6 and 3s1, because 2p subshell is completely filled here. That's why 11th electron will enter into the 3s subshell. And we can write this electronic configuration of sodium as in a square bracket neon and later on 3s1. What it means here, the meaning is that out of the 11 electrons of the sodium, first 10 electrons are distributed as same as the 10 electrons of the neon, isn't it? This in square bracket neon is written means what? It's a 1s2, 2s2, 2p6. And once the electrons are reached, or once the 2p is completely filled, then electrons are entering into the 3s. Okay, this is the electronic configuration of sodium. Then the next one is which one? After sodium, next one is a magnesium. Magnesium, atomic number 12. First 10 electrons as same as the neon. Neon I showed a few minutes back. And then there is a 3s2. 10 plus 2, 12 electrons. Then aluminium 13. Electronic configuration is neon. 3s2, 3p1. 10 plus 2 plus 1. In this way the 13 electrons of aluminium are being distributed. Silicon 14, very easy. Yes, try. It's a 3s2, 3p2. Okay, like this the 14 electrons of silicon are getting distributed. Okay, then after silicon, phosphorus is there, and it's a neon. Then here 3s2 and 3p3. You can show the orbitals now. Here S subshell is made up of 1 orbital, P subshell is made up of 3 orbitals, means 3 blocks. Okay, so this is about the phosphorus. I will show you about the phosphorus. Here 3s electrons, 2 electrons in the 3s are present in 1 orbital. 3p subshell is made up of 3 orbitals. So first, second and third. Like this 3 electrons of the phosphorus are get distributed. Now after the phosphorus, next one is sulfur. Atomic number 16. Electronic configuration as same as the neon for the first 10 electrons. Then 3s2 and 3p4. So 10 plus 2, 12 plus 4, 16. Isn't it? After the sulfur, next one is a chlorine. Atomic number 17. Electronic configuration is neon. It's a 3s2, 3p5. Okay, 1 unpaired electron is here in case of chlorine. Then there is argon, atomic number 18. here it's a, I'll write sequentially, okay na? In neon we may write either as a neon, or we may write here it as a 1s2, 2s2, 2p6, 3s2, 3p6, okay. So in this sequence the electrons are get filled. After argon, atomic number 19 is of potassium, its electronic configuration. Now here, instead of writing completely 1s2, 2s2, 2p6 like that, we can write here only Ar. Okay, right? It's a noble gas. Isn't it stable electronic configuration that argon have? It have a 8 electron in its last shell. So argon, and then it is 4s1. Okay, after the 3p electrons are entering into the 4s. So this is the electronic configuration of argon. What about the calcium? Calcium, atomic number 20, its electronic configuration is argon 4s2. Okay. Now after the calcium, it's a very important that electronic configuration of elements having atomic number 21 to 30. We call them as a 3D series elements. Okay. So scandium, atomic number 21, its electronic configuration is argon 4s2 3d1. Okay, 4s2 3d1. Now secondly, are you understanding? Here the total number of electrons are 21. First 18 electrons are get distributed as same as the argon. Then next electrons next to are there in 4s subshell, and the last electron is entering into the 3d subshell. This is about the scandium. Then there is a titanium, atomic number 22, argon 4s2 3d2. Only the one electron is to be added in the 3d subshell. Scandium, titanium, vanadium. Vanadium, it's a argon 4s2 3d3. Okay. Now atomic number 24 chromium is a slight. It shows a slight exceptional electronic configuration. Reason I'll tell you. 24th argon, actually it is expected it should be 4s2 and 3d4, but here 4s1 3d5, this condition is more stable. How the 24 electrons are get distributed? 18 plus 1 19, 19 plus 5 24. In this way the this is observed electronic configuration. Okay, at the end we will discuss the reason. After the chromium, manganese, atomic number 25, electronic configuration is argon 4s2 3d5. You know that the d subshell is made up of 5 orbitals, isn't it? So each orbital having one unpaired electron in the case of manganese. Okay, don't forget up to the manganese. Now next one is 26th is the iron. Iron, atomic number 26, electronic configuration is argon 4s2 3d6. After the iron, there is atomic number 27, and that's the iron cobalt. Cobalt, it's a argon 4s2 3d7. Only one electron is get added, isn't it? Say cobalt, this one. Now nickel is there, having atomic number 28, and its electronic configuration is argon 4s2 3d8. Then copper, as same as the chromium, copper also shows the exceptional electronic configuration. Its electronic configuration is argon. It is expected it should be 4s2 3d9. Okay na? But it shows electronic configuration 4s1 3d10. The reason is that 4s is half filled, 3d is completely filled. This corresponds to the lower energy and higher stability. And the zinc, atomic number 30, its electronic configuration is argon 4s2 and 3d10. Okay, 18 plus 2 20, 20 plus 10 30. Like this the 30 electrons of zinc are get distributed. So this is about the electronic configuration of these one. Now only two questions let me answer. The first one, that is why chromium and copper shows exceptional electronic configuration. So let's see here. Chromium atomic number 24, copper atomic number 29, and its electronic configuration expected as per the Aufbaus principle. Firstly, the which cell is to be filled? Firstly, 4s to be filled completely. So expected electronic configuration is argon 4s2 3d4, and observed electronic configuration for the chromium is it's a argon 4s1 3d5 is the observed electronic configuration. So why the exceptional electronic configuration these two shows? That's the question. Copper expected electronic configuration is argon 4s2 3d9, but the practically observed electronic configuration for copper is argon 4s1 3d10. The reason is that half filled or completely filled subshells correspond to lower energy and higher stability. In case of chromium, if we see 4s, S subshell can accommodate maximum 2 electrons. It is completely filled, so it favors the stability. But 3d, the capacity of d subshell is of total 10 electrons, but out of 10, 4 electrons are present here. So out of 10, 4 means it is neither full filled nor half filled, isn't it? If 5 electrons are there, it is half filled, but it is neither full filled and nor half filled. That's why it is not as stabilized. In this condition, S subshell can accommodate maximum 2 electrons, but out of 2, 1 electron is present means it is half filled. Half filled correspond to the lower energy and higher stability. D subshell can accommodate maximum 10 electrons, but here in this case 5 electrons are present. 5 out of 10 is the half filled condition. So this is the this corresponds to the lower energy and higher stability. Let's check for the copper. Expected 4s2 and 3d9. 4s2, S subshell consists of 2 electrons means it is a completely filled, correspond to the favors the higher stability and lower energy. What about the 3d9? 3d9 is neither half filled nor completely filled, isn't it? And we have another option 4s1 3d10. 4s1 means it's a half filled, 3d10 means it is completely filled. So this condition favors the lower energy and higher stability. That's why the chromium and copper shows this exceptional electronic configuration. Okay, it is the first thing. Now the last important thing that is about the formation of ions. Okay, actually too much time, the video is becoming too much lengthy. So in next video I'll make the remaining part. Okay, now how the ions of the 3D series element is to be formed. I'll give you the only hint. In the 3D series elements, scandium to zinc, what happens? The suppose scandium plus 1 electron is to be removed. Okay, now better I'll complete here. Okay, it will take few minutes. Scandium atomic number 21, electronic configuration is argon 4s2 3d1. But if I want to write the electronic configuration of scandium plus 1, scandium plus 1 means what? 1 electron is to be removed. The question is either 4s electron or 3d electron is to be removed. The answer is that the electron which is away from the nucleus should be removed first. Okay, now we know that 4th shell is away from the nucleus, so that's why 4s electron is to be removed first. Are you understanding? So scandium plus 1 means 1 electron is to be removed, and it's a argon 4s1 3d1. Here we have 2 electrons in 4s, out of that 1 is get removed. Suppose scandium plus 3. Okay, now if we want to do scandium plus 2, okay, so what should we do? Argon 4s0 and 3d1. So 2 electrons are to be removed, we should remove from the 4s only. Okay, now let's have the example of chromium, atomic number 24, its electronic configuration is argon 4s1 3d5, isn't it? Suppose if I want to write the electronic configuration of chromium plus 3 means 3 electrons are to be removed. What to do? Argon electronic configuration as it is, 3 electrons are to be removed. So just now we learned that firstly electrons from 4s are to be removed. Okay, if the 4s electrons are not adequate, then we should move towards the 3d electrons. So here it becomes 4s0 and 3d3. Okay, so chromium plus 3 electrons are removed, 1 from 4s and 2 from the 3d. And how many unpaired electrons we will see in the 3d? Here 1, 2 and 3. Okay, now d subshell is made up of 5 orbitals, that's why 3 unpaired electrons we will see here. Okay, so like this we can make the electronic configuration of the corresponding ions. Last example I will take about the zinc. Electronic configuration is argon 4s2 3d10 and Zn plus 2. So 2 electrons are to be removed means what? 4s0 and 3d10. All electrons are the paired one. Firstly 4s electrons are get removed. One last note is that if when we are adding the electron, the addition of electron is get favored by the subshell with the lower energy. Subshell with the lower energy will get filled first, isn't it? As per the Aufbaus principle, firstly 4s is get filled and the electrons are get entered into the 3D. Okay, addition of electron is favored by the subshell with the lower energy. Okay, and if when we want to remove the electron, so removal of electron depends upon the distance from the nucleus, isn't it? Here the fourth shell is away from the nucleus, that's why 4s electrons are to be removed first and then the 3D electrons should be removed. Okay, in this video what we discussed about the electronic configuration of elements having atomic number 1 to 30. Okay, bye all of you, thank you.